Now we're going to look at vector operations. So what does it mean to have one vector adding another vector? So let's say this vector here is this one here, and this vector here is this one here. So what does it mean to have one vector adding another vector? So imagine you're an ant. This vector is telling you to move in this direction. Well, move 4 across, 1 up. So imagine you're an ant. You're moving along here, and then this vector is telling you to move along here. So the resultant vector would be from here to here. See, if you get this vector and add it to this vector, it will give you the resultant one. So let's just say this here is W. This vector here is W. So W equals equal 4. So 4 plus 2 would be 6, comma 4. So oops. So you're moving 6 across, 1, 2, 3, 4, 5, 6, and then 4 up. 1, 2, 3, 4. So it will have the same effect. And if you think about it, the reason why it works is, well, if you just look at the horizontal movement, you're moving 4 across, and then later on you're moving another 2. You're moving another 2, and then now look at the vertical component. You're moving 1 up, and then later on you're going to move 3 up. So in a way it kind of makes sense. Even if you have a third vector, let's say the third vector here is W here. So this is a different W, and then let's just say the resultant one is let's just call it Z. Okay, so now just looking at, so imagine you're an ant. You're moving from here to here, and then later on move up here, and then later on move down here. Well, that's the equivalent of you moving 2 across and then 2 up. And the reason why is because of this. Let's just look at it horizontally. So we're moving in the horizontal direction. So let's just consider the horizontal direction. I'm moving 4 to the right. 1, 2, 3, 4, and then I'm moving another 2. 1, 2, and then I've got to go back 4. 1, 2, 3, 4. So I'm going to end up here, which kind of makes sense. And then looking at it vertically. So vertically would be us moving in the vertical direction. So looking at it vertically, I'm moving 1 up, and then I'm moving 3 up. 1, 2, 3, and then I'm moving 2 back. 1, 2. So that's the same as us. Well, I hope you can see it kind of makes sense. And in the future we're going to look at something like 3. Let's say 2 V here. So that would be, so 1 V would be from here to from here to here. So 2 V would be you doubling the distance in the same direction. So it would take you to here, from here to here. Well, I will explain this another time. But then you can extend this concept of adding vectors to 3D as well. 3D. So when it comes to 3D, just think about you moving in the direction. So you moving in the X direction, and then later on think about you moving in the Y direction, and then think about moving in the Z direction. So you can extend the same idea. So just think of it as being you moving. So you adding all 3 together. It's you moving 4 across, and then moving another 2 across, and then 4 back. So think of it as you moving along here. So it kind of makes sense. And then later on consider moving it vertically. So when you add vectors, you simply just add these. Okay.